So we quickly looked at what your interpretation of welding symbols with information added to the tail, such as SMAW dash MA, and we talked about how that was just simply extra processes or extra requirements associated with a specific process. The dash just separates the two. Well, let's take a few moments just real quick to talk about these extra conditions or this extra information that is shown. So, a specific welding application associated with a welding process. So this is the application, this is the process. And while we're here, let's start off with MA. You see MA at the end of a tail, that is what we're just a basic manual welding application. And I can't spell welding today, there we go, welding application. Zoom in a bit. So this is your typical manual, this is your typical welding as we think about it. This is the technician actually holding the equipment. Could be the welding gun, could be a torch actually. This could qualify as a torch. So even though I say welding, it could actually be, I guess you could actually fall it into cutting a little bit. But actually torch, no, it's probably still welding because they're still using the torch to weld. Basic holder manipulated by the hand is the key thing here, and it's completely controlled by the welder. So when it's manual, that's the key thing too, is completely controlled by the welder. No machines, no robotics, nothing like that. You're just got your equipment and you're it. Now, another condition or another application is your semi-automatic. And your semi-automatic process is, manual plus some assistance. So, for example, GMAL would be or gas metal arc would be an example of this, where you're actually using your hand to guide the weld, but the wire system is fed for you. And so that is a semi-automatic, and which is pretty much how that whole process works in general. So I doubt you'd actually ever see that laid out into detail, unless there's something else specially. So semi-automatic, you're manually controlling, but you've got some assistance. If you were to see an ME, that means mechanized. Let me just go ahead and type that out. Mechanized welding. So dash ME is mechanized welding, and it essentially is sort of set to be automatic, but with adjustments being made. So you can almost think about this as being a guide. So let's say you have the gun and it's actually held by a jig, and the system welds with a guide, but an operator is still there overseeing and making adjustments. So let's just say that it was on some kind of wheel system going back and forth, and the operator may have to tweak a little bit here or there. It's under constant observation. So mechanized welding might be something for a little bit higher precision, where you don't want the the welder to get off, or quality and control really matter. But it's not really fully automatic, because there's still an observer and an operator required, and diligently required, especially to deal with changes or what they see happening to make adjustments. However, your AU is your automatic welding, and this process it requires minimum observation, so you don't have to be there making adjustments and watching it, and typically no manual adjustments of controls. So automatic welding is much more manufacturing type situation. You're going to be doing over and over and over, and the equipment completely controls the welding process. Now you may say, well, what's the difference in that and robotic welding? And we're actually still talking about two different things. Automatic would be that it's set up and executes a particular process, and let's say it's just going to weld from here to here, and it does it totally on its own. Just welds from here and here and here and here. But it's not something you can turn around and change out. You'd have to change the whole equipment out to get a different type of weld. So, and we'll see how that's different than robotic. So it's a completely minimum observation operation, but it's kind of consistent. It's the same weld over and over and over and over, and doesn't allow itself to change without massive, adjustments to equipment. And also keep in mind that an automatic welding is not really adaptive. So if something happens, it doesn't make a change. It doesn't see any error in the way it works. It would just keep doing it. If like there was no plate underneath it, it would just keep welding over and over and over, or keep trying to. All right, so that's automatic. Now we actually have the other one, referred to as AD, which is adaptive control welding. And this is like automatic with extra features. So yes, it can do this over and over and over, minimum observation, but it's a system that can make adjustments as needed based on input or, I don't know, some kind of sensors perhaps to see if it's off and make slight adjustments. It's not robotic though, because it's still going to be the same weld over and over and over, but if something's up or needs a little tweaking, it can make those adjustments itself. Again, minimum observation, and that's adaptive. Let me type that out for you. That was adaptive control welding, which again was AD, adaptive control. All right. Now, last one is robotic welding. Now this is sort of like, by the way, it's RO. This is sort of like your machine's taking over situation. Now it is capable of doing one weld. It is capable of kind of making it, well, it's capable of doing one weld over and over and over. And more importantly, it's capable of changing the weld. So let's say we need to do this pattern instead of the last one. It's all based on someone programming it. So they write the code that actually tells the robotic welder how to execute, and this thing will execute it over and over and over. Now, one of the neat things about this programming is there's a couple ways to do programming with robotics. You could actually just, there's software that will actually take, your design essentially, or your need, and it will write the code with the computer program, write the code to the welder. And by the way, robotic welders, if you haven't seen them, look kind of like this. Here are your typical images of robotic welders. They're a multi-axis system, very arm-like, that feed the wire in and can move in all kinds of different directions. So becoming very, very commonplace in many industries. Very advanced, very handy. Now they do allow for some controls and manipulation. They even allow some live action kind of thing. But the idea is to always make it automated. So we want the actual robotic process to be a program. But here's the cool thing about it. You don't necessarily just have to design a code into it and it write the code, or design a feature and it write the code and tell the robot what to do. You can also teach the robot what to do. There's actually ways that you can manipulate the control arm as sort of a practice run, and it follows those movements and then repeats them. It sort of learns the weld it needs to do. This actually is being done in a lot of different robotic applications where we can teach robots how to move and teach them tasks by pushing and pulling them and giving them a demonstration. And then they write their own code and then execute that over and over and over. Very, very amazing, very cool, and very much becoming a big part of the industry. So it's one of those things to take advantage of if you have any opportunities to become skilled in robotic welding. Make sure you do so, because this stuff right here is just taking over. Now, while we're on that topic, I'll just go ahead and point out a few things. This is a great little opportunity for us. So here's a situation. Now, that's not what I want. Here we go. So here's a situation. Notice the robotic welder sitting in place. One thing you got to watch out about any type of robotics is the safety zones, because these machines are typically programmed just to keep on going. So if a person gets into these zones, they could potentially be injured by the robot passing around. So that's why operators are often, supposed to be well trained, and areas are clearly marked in terms of how much of a space the robotic system needs to do its job, and for it to be clearly marked on the floor so you don't get in the robot's way. Now, some other cool things about that though, and I'll show you real fast. With that concept in mind, the new age of robotics is kind of entering in, where we have robots being put into manufacturing situations where they actually can do more than just welding. They can do all kinds of tasks. These, for example, are robots. This is Sawyer and Baxter. I don't remember which one's who's who, but anyway, one of them is a one-armed robot, one of them is a two-armed robot, and you can teach them. So you can actually put them into a programming mode, teach them movements, change out their manipulator arms, use them to store products. You'll notice they actually include these little eyes on here, so you know what the robot will actually kind of look where it's going. Not really look, obviously, but what it's doing is trying to let you know what its next action is going to be. So you know, if you're interacting or something and it was turning its eyes to the left, you know it's going to go to the left or do something. It's also got a programmable interface, and the cool thing, it's got all these sensors on it, so if it does bump into something, it immediately stops itself from doing anything else. That way it doesn't potentially hurt someone. They actually have some examples where they'll have these things giving people hugs. Cool thing about it also is that it doesn't require a lot of setup. These are actually fairly inexpensive robots, so to speak, in terms of comparison, and they can run off simple 110 power. So we're starting to see a lot more of these type pieces of equipment in the manufacturing realm. These are actually still based off the same concept as your typical robotic welders. So, you know, that technology is coming. If you can get involved with it, make sure you do so. Huge applications and a huge future for all those related industries. So, as far as all that goes, you know, we've got all kinds of technology that can be tied to this, and those are extra applications that you'll probably see you may see in the tail of a weld symbol. Remember, it's the dash and the actual application. This is the process. This will be the application maybe tied to it to pay attention to. All right, so that's a quick little one, and we'll see.